Hello, everyone. Thank you for joining. My name is Patrick Moran, and I'm the Community Manager for Apex Users Group. Your presenters today will be Ashwin, Product Manager at DataTorrent and Committer for Apache Apex, Sanjay, Engineer at DataTorrent. This webinar is being recorded and will be made available on YouTube after the session has ended. Presentation slides will also be posted on SlideShare. Feel free to ask questions throughout the webinar. We will answer them as they come in, and we'll also leave some time at the end for a Q&A session. So starting us off today will be Ashwin.
All right, yeah. Hi, everyone. This is Ashwin, and today we are going to talk about the Big Data AppHub and application templates and how these application templates are going to reduce time to value to take your big data applications to production. Before jumping into application templates, let me start with what DataTorrent's vision is and how we started it as a company and how application template fits into this vision. Right. So our focus when we started out and going forward is to really focus on productizing and operationalizing big data. Right. When we say productize and operationalizing big data, we want tools that will allow you to be able to launch in production fast. Right. And then reusable pre-built applications or pre-built operators that help you go to production faster. Right. And also operationalize in the sense that while you're in production, all the long-running applications, your big data applications, doesn't need a lot of human intervention to be able to keep up and running for long periods of time, right? So essentially what it boils down to is focusing on these three areas: time to develop, time to launch, and cost of ongoing operations. And app templates essentially reduce a lot of your time to develop and time to launch. Right, but in general, what we do is we focus heavily on simple interfaces, pre-built applications, code reuse, debuggability, monitoring, and management of your running applications, and so on. Right, so that way we focus heavily on productizing and operationalizing it. So before going into more details about the templates itself, we need to understand what's underneath and what makes it a big data platform, and how these application templates will help you. Is essentially any big data platform, right? Especially when you're focused on streaming or batch-related architectures, you're expecting applications to be running for long periods of time, right? So, and it comes with certain expectations if you want to build your applications on top of these platforms, right? So these are the few top-level expectations. So one is that you should be able to read data from various types of sources, right? Like your IoT data or message buses, data from your file systems, databases, or social media data, click streams, and so on. And also be able to process this data, right? After you're processing, land this data into various types of sinks, like again, back to message buses if needed, or write to file systems or databases, right? And even visualize them as your data is being processed. So if you are calculating some KPIs or dimension aggregates, you should be able to take those calculations and then visualize them on the fly as your data is being calculated, right? And other requirements are be able to process both unbounded and bounded data. Unbounded is excuse me. Unbounded is streaming data, right? So there is no boundary. Your data is continuously flowing in. Let's say you're reading from some message bus, and there is no boundary in terms of when the data will end. Right? It is continuously coming in, right? So we should be able to cater to such type of data, but also we should be able to process batch processing where there is boundaries defined. For example, let's say you're getting your data into a directory as files once every day, right? So you should be able to process this data as soon as these batches of files are available, and then do that as fast as possible, right? So that's the requirement there. Another thing is do in-memory processing. So when you're talking about low latency, being able to get your insights as fast as possible, essentially what you want to do is while your processing is happening, you don't want to hit the disk, right? And as soon as you're hitting the disk, you're slowing down your processing. So all the processing should be happening in memory. And while this processing is happening in memory, you have to take care of constraints such as fault tolerance, scalability, and all of that. right? And the other big requirement is stateful operations. With stateful operations, we'll be able to achieve use cases such as aggregations, rules, and analytics, and so on. So the platform that DataTorrent has is called DataTorrent RTS, and it has an underlying engine called as Apache Apex, right? And which is the distributed data processing engine, which does both batch and stream processing. And so Apex actually has all of these features. So it caters to all of these needs, right? And below, here is a typical example of how an application might look like, right? So let's say you are serving a website, you have a web portal, and you're continuously generating logs, right? So for example, if it is a social media website, and you're continuously having users on your website, and then now you're continuously generating these web server logs, and you want to be able to analyze these logs as they're being generated, right? So a typical architecture would look like the following, where you would continuously keep injecting these logs into a message bus, let's say Kafka, for example, right? And then a platform like Apex comes in after that, which continuously reads this data. So it will be able to read the data from the message bus, and then it also should be able to, like, if it is a compressed event, you should be able to decompress it, parse it, filter it, and so on, right? And then once you have your data prepared on the fly as your data is coming in, you should also be able to do processing on it, analytics on it. For example, you want to do some dimensions aggregate and then show it on a UI, right? So anybody who is monitoring it will be able to immediately see what is happening with your data, right, as your data is being generated. And you should be also take this data and then write it out into a message bus, for example, or a database, or a data lake for downstream analysis later point in time. So this is just an example of how an application in Apex might look like, right? And you can have many other applications similar to this using the constructs that are available on Apex. So essentially, if you look at the top down picture, a very high level view. So if you have a big data architecture, typically it looks something like this. You have your data sources all the way to the left, things like your sensor data, social media, app server logs, or click streams, and so on. And then you send this data over to something that we like to call as a message delivery systems, right? So for example, your message systems where your messaging queues where your data is continuously being injected to, like Kafka or Solr systems, or file systems such as Amazon S3 or HDFS, and so on, and even databases, traditional databases, right? So all of these become sources of data that you can read from to do your processing. And DataTorrent and Apex essentially are the processing engines. So there are connectors to be able to read from any of these sources, right? All your data, and then do a bunch of processing on it using something called as operators. So each operator is a functional unit of work that you do on top of Apex. Now, once you do this, Apex also has connectors on the downstream where you will be able to write to various destination sinks. For example, be able to write to your data lake, or be able to write to your traditional store like Oracle and MySQL, right? Also NoSQL stores like MongoDB, and so on. There are many different connectors that you can write to. And then there are visualizations on top, which you can perform on top of Apex and DataTorrent. So I have been talking about Apex and DataTorrent synonymously. So there is the architecture diagram paints a clear picture about what DataTorrent is and what Apache Apex is, right? So Apex at the core is a distributed processing engine, right? It does stream and batch processing, and it runs on top of Hadoop. 2.0, actually it's 2.6 now, right? So if you have Hadoop 2.6 or plus, you'll be able to run Apex on it, the latest version of Apex. And it depends on YARN and HDFS, so it's native to Hadoop. So you don't have to have your own resource manager or a distributed file system on Apex. It relies on whatever Hadoop is coming with, right? And so Apex core as an engine, this particular layer, what it does is it is responsible for many different things regarding your application. So for example, you're launching an application that reads data from Kafka and writes to HDFS, right? And maybe you do some processing in between, like parsing, filtering, and some transformations. Now, to be able to run this application, when you launch this application, what Apex does is it takes your application and then it talks to YARN and gets containers for your application, right? So let's say you need about 10 containers for it. So it talks to to yarn get those containers, take your application's individual operators, create multiple partitions of it, and deploy in these containers, right? So what happens is it helps in terms of resource management, in terms of deployment of your application. And then once your application is launched, it also keeps track of things like heartbeats and so on. So it can take care of fault tolerance, right? So if a process goes down, what Apex Core guarantees is that it restarts that process in some other container and from where it left off. So essentially, from a user perspective, it's as if nothing has happened and your data is intact, right? You don't have any data loss or you don't have any repeat data going forward. So that's all the responsibility of the Apache Apex core. And on top of that, we have something called as a Malhar operator library, right? So the core engine itself is responsible for all the constructs such as fault tolerance, scalability, performance, and so on. But if you have to build your application, you need to be able to have those functions that read data from your source, does some processing, and then land it in your destination, right? So, for example, if you're reading from Kafka, you need a Kafka input operator, right? And then if you're passing JSON, you need a JSON parser, right? Similarly, if you're doing filters, transforms, aggregates, so you need a lot of operators to be able to build the pipeline that you can go to production with on your use case, right? So Malhar library is essentially those individual constructs, individual operators that you will use to create your applications. So both of these layers are essentially Apache Apex. They were built by DataTorrent since 2012, and around 2015, we contributed the project to Apache, right? So right now it's owned by Apache Software Foundation, and all of the source code is free and usable on the public domain. And Apex, even before it was open source, it was being used by a bunch of customers in production. So it was pretty hardened even before it got open sourced. Right, so both these areas, both these layers are Apache Apex. Now, what DataTorrent adds on top is these two things, right? In terms of the applications, industry solutions, and application templates. And this is what we are going to talk about: application templates. The templates are nothing but reusable patterns in terms of a technical use case. Let's say, if you're reading from Kafka and writing to HDFS, that's a use case, right? So those are the templates, and the industry solutions are the templates and these operators put together to solve a particular business use case, industry vertical use case. Let's say, for example, financial services fraud prevention is a solution that is built on top of these operators and these application templates, right? And other things that DataTorrent provides is tools on top that will help you in many areas such as development, management and monitoring, and visualization. So we have a lot of built-in visualizations that will help you in monitoring your data or building KPIs in real time. So as your data is flowing in, you'll be able to aggregate that data within a few milliseconds. You'll be able to take that data and basically make it available on the visualizations, right? So you'll have many charts such as bar charts or pie charts and so on. So you can actually create your business KPIs and then show the data moving in real time. So you can act on it as soon as the data is available to you. And other thing is the management and monitoring console. So basically, Apex applications are built to run for long periods of time. So they are streaming applications. So you'll see applications running for months. So essentially, what becomes important is in those applications, you want to know, you want to monitor them continuously as these applications are running. So the management and monitoring console gives you very good capabilities in terms of looking at various metrics, right? Operational metrics such as throughput and latency at a very individual process level. You'll be able to access logs directly from the UI, and then if there are any events going on, if something failing, something is restarting, all of these events are shown to you on the UI as root causes, right? You'll be able to look at exceptions at a root cause level. And if you have critical paths, or if you want to go look at the stack trace or GC logs, so all of this is available on the UI. So it's pretty cool. You'll be able to put alerts on it, right, as well. So if the container goes down, you want to alert your admin, or if a series of events happen, you want to alert your admin, so you can do all of that, right? So Let me see if I have any questions. So, okay, all right, no questions. So, going to app templates now, given the background, so we have the Apex core, we have the operators, and DataTorrent has a bunch of tools on top, right? So, now what we have seen is while talking to customers and while talking to a bunch of users, there are a lot of repeatable patterns in terms of the use cases they do, right? And when we look at these repeatable patterns, if we take these applications in terms of the patterns and then build templates out of it, now, what happens is your time to market goes down drastically, because if you have to start from scratch, where you have to take these operators from Alhar, build your application, test it around, and then scale it, and then go to production, it takes a significant amount of time, probably a couple of weeks for a basic application, right? And what we're doing with application templates is looking at repeatable patterns and then providing them as pre-built applications that you can start with. So basically, what you can do is import and launch it quickly from something called as AppHub that we have on the DataTorrent RTS console. So within a few minutes, you'll be able to launch this application. And if the application itself caters to your need, you don't have to add any more custom logic, right? But if you, let's say, if you have any more business logic, we also made it easy for you to extend this application, add more operators to it, and then launch from there. So we will talk and show demos around both of those capabilities. And so when we are looking at these patterns, right, so there are different types of patterns that came up. So essentially, the very basic pattern that we have seen, a lot of people want to do is just move data, right? From point A to point B, for example, without any processing. For example, disaster recovery use case. You want to take your data from your production HDFS cluster into your backup HDFS cluster, right? Your production data lake into your backup data lake. Or if you want to ingest your streaming data as it is coming in, let's say from Kafka or from RabbitMQ, ActiveMQ, and then land it onto your data lake in raw format, right? Or you want to take your traditional transactional data, JDBC, and once every few hours, just dump the data into the data lake, right? Or maybe continuously keep ingesting your transaction logs into your data lake. Or other use cases are like, take data from your cloud file system and then get it to your local file system like S3 to HDFS, or do it vice versa. So we have seen these patterns. So what we have done is we created those templates of point-to-point templates, which doesn't have any processing in between. So those are the first set of patterns. And others we have seen is really the ingestion patterns, where you take data from your sources and then do some processing in between, essentially data preparation, right? Do some data preparation and then make it available in your data lake or a distributed source such as Cassandra and MongoDB and so on. So what you want to do is take data from your HDFS or JDBC or Kafka, do some parsing, deduping, enriching, format, transform, and so on, and then finally land it onto your data lake. So we have templates for the data ingestion use cases as well. And other use cases we have seen these days, especially becoming more popular, is instead of ingesting to your data lake and then do post processing, what we have seen is people are moving their processing left into in motion, right? So while you are ingesting your data, you might want to do things like machine scoring, or you might want to do CEP rule execution, or you might want to do aggregations and then show it on your analytics UI and so on, right? So why wait until the data lands into your data lake if you can make use of the data immediately as it is available? So we are seeing those use cases as well. So we're building those patterns going forward as well. Right. And as I said, so as these application templates are being built, we need a very quick way to make it available for users so they can quickly try them out and then customize it and go to production. So what we created is something called as AppHub. If you go to the DataTorrent UI, the console UI, you'll be able to see in the navigation bar this item called as AppHub. You click on it and you will see all the applications that are available today. So we are continuously building out applications, maturing existing applications, and adding more capabilities, functionalities to it, and then pushing them to the AppHub. So whenever you have an application need, you will be able to, you can quickly go here, do a search for the type of sources or destination type of processing you want to do, or even industry solution use cases, right? You'll be able to go there and search pretty soon, and then be able to see a list of the available templates or solutions, and you can download from there, right? So that's a pretty cool thing. So that helps you quickly import and launch your application. So essentially, right, what we're doing with all of this is bridging the TTV gap, your time to value. And we achieve that by the following components that we have all through within the infrastructural areas of delivering app templates. So one thing is AppHub that we just talked about. It's essentially the delivery mechanism. And then we have heavy focus on cloud integration. So one of the demos you will see today is be able to just download and install a script from the website for a given app template, and then run the script, and then basically behind the scenes your application template is available to launch in your cloud infrastructure. So in this case, what we will do is download an AWS installer. The only expectation is that you have AWS account, and then what it does behind the scenes is basically deploy EMR for you, right? The Amazon's Hadoop, and then install DataTorrent in it and get your application template available. So all of this is hidden, and it's automated behind the scenes. And what you will be able to do is just get to business immediately in terms of your use case, right? So that helps reduce time a lot. And other thing is schema support. So all of these templates, we are making it agnostic of schema. So essentially, let's say if you're reading from Kafka, doing some JSON parsing and processing and writing to HDFS, you can take that exact template and then apply it to different use cases, right? So for example, if you're ingesting healthcare provider data, right, and you have a particular schema for it, and you'll be able to apply the schema external to the application template. Now you can take the same application template and let's say you want to ingest financial transactions in JSON format, right? Then you can apply that schema on top. So what happens is this opens up a lot of use cases on a given template, and then you don't have to go to code and change schema or change any logic there. If it caters to your business use case, you can immediately go to production with it, right? So, and the other thing is open source code. So every application template, it has a corresponding source available on GitHub, and you'll be able to clone it and then add custom logic in terms of more operators or any enhancements to it, and then make changes on that application software, on that application code. Right, and the other thing is application level metrics and visualization. So since DataTorrent has the real-time visualizations capability, what we are doing is we are adding pre-built dashboards, pre-built bundle dashboards into this application template, so that are relevant to the template. So for example, if you're moving data from S3 to HDFS, you might be interested in metrics such as how much data are you moving in terms of number of gigabytes, or you want to know number of files or number of files per day, and so on, right? So all of those metrics will be available that are relevant to the application template. So overall, the benefits for an end user are like this, right? So there's ease of use. You'll be able to quickly import and launch your template, and then you'll be able to easily add business logic by adding custom operators to it. And then other real focus is time to market. Reduce your time to production drastically, because these templates are pre-built, tested, and uploaded by DataTorrent, right? Another thing is because of the underlying infrastructure that you have from the management and monitoring capabilities of DataTorrent, your cost of operations is also pretty low, right? So that's another advantage. And then you have real-time visualizations, as I was just talking about. So you'll be able to use the pre-built bundle dashboards to be able to visualize some metrics relevant to the application. And other cool thing is these are not, the visualizations are not really written in stone. So as a user, you'll be able to add more metrics and add more widget. And then if you want to have your more business-focused KPIs, you'll be able to calculate, you'll be able to add those calculations into your application and then publish them on the UI. So that makes it more relevant to your business as well. Right. So with that, I would like to hand it over to Sanjay to do a demo on two templates, Kinesis to S3, and that he will do with the AWS installer. So you will see that it gets installed on AWS with the EMR deployed and so on, without user having to manually configure, install and configure. Another one is moving data from HDFS to S3. So both of them we'll do. And meanwhile, if you have any questions, feel free to ask them. And I see one question, so let me take a look at it. So what is the difference between monitoring portal and YARN resource manager? Good question. So YARN resource manager essentially gives it a very high level some view in terms of basically what is the status of your application, and it gives some access to logs from there, right? And other than that, you will see percentage completed, and you will see more at the container level, number of containers, or you will see like number of nodes and number of applications and so on. what the monitoring portal shows in DataTorrent is a lot more granular than that. It's more specific to your application. It shows literally the operators that are in your application at the logical level and the physical level, and you'll be able to see very granular metrics at a second level in terms of the throughputs and latencies. Actually, let me quickly show you if I have the management and monitoring console open. I think it'll just take a few seconds, so I'll just open it and show it to you. So those metrics are like super granular, right? And then you'll be able to see various events that are happening within your cluster and so on. So okay, if I go to the monitor tab here, I'll take an example. For example, the Twitter demo, right? So if I drill down into it, now it shows here are the operators for your Twitter demo. There's a tweet sampler operator, unique hashtag counter, top counter, and so on. And you will see, like, here it says current window ID at the top. Now let me put it as process per second, and then put this as emitted per second in the below. So now you'll be able to see how many events it is processing every second. So this is real-time data that is coming up, right? And then you'll be able to see things like latency, like how much latency. This is literally like 2 milliseconds of latency in this operator. You'll be able to see CPU and heartbeats and how long it is taking and so on. And then I was talking about these events. So essentially, when this application started, it got certain number of containers from YAMLs, right? So it now says that these containers are started, right? And then as soon as the containers are started, each of these operators are deployed there, and these operators have started. And then this is the logical view of it. You can go to the physical DAG view. In this particular case, there is only one instance of each operator. So let me go see if I can find something else which has more than one. So for example, this telecom demo, right? So if you see logically, there are all these operators, and let's look at the store service KPI, right? If I go to physical DAG view, now I'll be able to go see that the store service KPI has 2 partitions. So at this partition level also, now you can see various metrics, right? So you'll be able to see that, hey, the first partition is doing about 50 events a second, and the second partition is doing about 50 events a second, right? So similarly, there are a lot of different things that you can do. Feel free to download DataTorrent RTS from the website. You have a free version that is available, and you'll be able to use all the features until 128 GB of memory, right? So feel free to explore, and ping us if you have any more questions. All right, I think that's the only question I had. So let me hand it over to Sanjay so he can do the demo for the 2 application templates.
Thanks, Ashwin. Can you see my screen?
Yeah.
Okay, good. So Ashwin talked about our app template and the AppHub that is present on the DataTorrent website. So there are 2 parts of the demo that I'm doing. First part is for an app template that is Kinesis to S3. That is going to be a template with EMR integration. So I'm going to show you how you can go to the DataTorrent website, register yourself, and download the EMR deployment script. And using that script, how you can deploy an EMR cluster, the DataTorrent RTS application, and the Kinesis to S3 application template inside RTS, DataTorrent RTS in there. And the whole thing, is takes about 10 to 15 minutes. So while it is doing that, I'll actually run the template itself, Kinesis to S3, on our own dev cluster so that we save time. And for those 10 minutes, we can do something useful. That is the first half of my demo. The second half is just running the template HDFS to S3. Both of these templates are an example of the ingestion category that Ashwin talked about. It shows you how you can easily download these templates in case you have your own Hadoop cluster and your own RTS instance in that cluster. You can download these templates and install there and run them. But in case you don't have any on-premise hardware or on-premise cluster, you can just create an AWS account and you can deploy our whole application stack in AWS using your account credentials. And in 10 to 15 minutes, you can actually have the app template up and running, which is what I'm going to show you in the first half of the demo. So let's get started. You go to the DataTorrent website, go to AppHub, and in AppHub, there are various templates that are listed here. The one that we are going to demo, the first one is Kinesis to S3 app. So let me click on that one, the title of that small panel. In this page, there is a description of this app. It talks about what the app does. Application scales linearly with number of shards. I have 8 shards in my Kinesis stream, so it's going to create 8 partitions. We'll see that when the template is running. It shows the logical plan as a graphic here, but when I'm running the template, you'll be able to see that in the monitoring portal that Ashwin briefly showed you by going to the demo website. So anyway, to download the EMR version of this, you click on the download template button. Over here, it says don't have DataTorrent RTS, no problem. The left-hand side is to download the template binary to run in your own Hadoop cluster. But what we're going to do is the one on the right-hand side, which is to deploy the whole stack in AWS, your own AWS account. So of course, the prerequisite to this is that you should have an AWS account and you should have your AWS keys. And because this script also uses the AWS CLI, you need to download the CLI on your computer. It's not too difficult. Just search for AWS CLI. And on the Amazon website, there are pointers to how you can download this on your computer. So on Mac or Linux, you can just install Python, and using the Python installer pip, you can install the AWS CLI using this command. I have already done that. So what I'm going to do is I'm going to show you once this is done, so I can invoke the AWS command. This I need to configure this command with my AWS credentials. So typically I say AWS space configure. It prompts me to enter my access key, my secret key, my default region name, which are the attributes corresponding to my AWS account. I have already entered them here, and I have configured my AWS CLI using these values. Once this is done, I'm actually ready to download my AWS template, and let's see how to do that. So I click on the here. I need to register. So let me just register and enter my details. This is to the meetup, so let me click on agree and continue. So this will give me these 2 links. The first link downloads the installer as a zip file. The second one downloads the license. I need to input the license in my my setup. So I have downloaded both these files. Let me look at my zip file. It's a zip, so let me extract it. It's in the folder now. So you'll see once I unzip my zip file, I see these 3 files. I go to that folder, and I see these 3 files here. One is the config properties. The other 2 are shell scripts. I need to make my so the one that we are going to use right now is DT app deploy. I need to make it executable. So it's executable now. And the other thing I need to do before I actually launch this is see if I need to tweak my properties. Typically, these don't need to be tweaked, but let's say if I can kind of customize it or personalize this. So I'm going to call this webinar 2. So this cluster, when it shows up in my EMR cluster UI, I can see that cluster name. And the only other thing I need to do, which is better for this, is I'm going to create a cluster with 12 core instances, because typically the template I'm going to run requires more than one containers. It requires, because I have the Kinesis stream with 8 shards, I would need at least 8 partitions. So let me be generous and give it 12. 12 plus 1, which is for the master. And let me see, I've done everything right. So let me save this, and I'm ready to run it. Before I run it, let me go back to my EMR console. I have the, I have kind of tried these things before, so they show up in my EMR console. Once I start running it, it will take some time. It will take maybe 10 minutes. So to avoid having to wait 10 minutes, I'm just going to run the template in my already running DataTorrent RTS instance in my local cluster. So let me launch my deploy script. It has started running, and it is invoking the AWS CLI. So it's going to take some time. It is going to create this U8Y. Let me see whether it has started to do this. Yes, it does show it's starting. So it is creating this EMR cluster. And because I don't want to wait 10 minutes for it to be up, I'm just going to go back to this RTS instance I have in my own Hadoop cluster. And I have already imported Kinesis to S3 package in this instance. And so I'll show you, once this particular cluster is ready, I'll show you how I get to this UI and how we'll be able to run it over there. We won't run it there, but there is no difference whether I run it here or run it there. So Kinesis to S3, let me launch it. I think Ashwin briefly showed you this UI. I'm actually going to use it to launch the application or the template. So now the whole thing runs on Amazon. The EMR cluster itself is in Amazon. The S3 output itself is based on Amazon. Kinesis input is also in Amazon. So I have all of these tabs open. On the S3 output, I have, I have to create buckets for my S3 storage. The bucket I'm going to use is DT demo Kinesis to S3. And I'm going to specify this as a bucket name and an output folder to write my output to. I have a little cheat sheet here to copy the values. So let me start entering these into my application launch dialog box. This is the S3 output bucket name. This is the S3 output path. I'm going to use something that is for this particular demo. So let's say output webinar demo 2. We'll see this getting created on the output side. The access key for my AWS account, not only I needed this to create the EMR cluster, I also needed to access both S3 as well as Kinesis. So let me enter that for both of them, access key for Kinesis and access key for S3. For both of them, I'm going to use the same credentials because I happen to be using the same account, but in theory, you can use this template to read from one account and write to another account, okay? This is the endpoint name for Kinesis input. The secret key for both of them. Now, on the stream, the Kinesis input stream that we'll be able to see here in my Kinesis streams console, I have these two streams available. The one that I have populated is transactions. It has 8 shards, like I mentioned. So my application is going to create 8 partitions on the input side to read from these shards in parallel. We'll be able to see that. Anyway, my the name of my stream is transactions, so let me copy that as the parameter value in my app template launch. I'm going to put it here. Now, this is not enough for me to run this app because I need to provide some more properties, especially for the demo as opposed to production, because a demo we need to quickly see the results. So what I'm going to do is I'm going to reduce the size of my S3 chunks. So I'm going to reduce it to 1 megabyte. So we'll be able to see the chunks getting created on the S3 side. Sorry, and not this one, but this one. I'm going to make it 1 megabyte. Also, the partitions, I'm going to reduce it from 16 to 4. I already did that here. And the other thing I need to do is I need to provide for the Kinesis input stream where I should start reading from. So typically applications start reading from the current offset, but for this demo, since I'm reusing this stream, I'm going to start reading from the earliest offset available. So let me specify that. Let me verify my property values so that our demo runs successfully. Transactions, the size in bytes, number of partitions is 4. Earliest. I think we are ready to launch. So let me launch it. So this RTS console takes the application package, creates a DAG out of it, then sends the DAG to Yarn, Hadoop Yarn, and tells Yarn, basically requests a certain number of containers from Yarn. And once Yarn has accepted that particular request, the status of my launch goes to accepted. So at this point, Yarn has accepted my request, and it is kind of preparing the containers. The containers are prepared and they're started. The Java code is transferred to those containers. And once everything is all ready to run, my application goes into running state. The application has gone into running state. The containers have been started. The operators inside those containers also are processing data. You can see how the DAG, this is my logical DAG, how it is reading data from my Kinesis stream, which is here, from this stream transactions, and how it is sending it to the S3 output module. And my S3 output module has 2 parts. First part is compaction. It does some optimization where instead of sending each tuple as a line to my S3 output side, it will compact all of the input tuples up to some limit and send the compacted data to the downstream operator inside that module, which is the output module. This guy takes the data, assuming this was partition, it actually takes the data from the multiple partitions, reconciles them, orders them, and then puts them back into one block and sends that block out to the S3 side. So currently the compaction phase is still processing it. So you see that it has emitted 1, that 1 has gone, so the one huge tuple has gone to the downstream operator here, which is the reconciler. And this one is going to send it out to S3. Now, one thing is the UI is so beautiful that I click on this operator, I'll be able to see the properties that I supplied in the launch dialog box. In this, you can see the directory name on the S3 side. The bucket is dt.demo.kinesis to S3, and the directory name where it got created is output-webinar-demo2. Let me go to my S3 console, and so the bucket was Kinesis to S3, dt.demo.kinesis to S3. Let me go to that bucket, dt.demo.kinesis to S3. under that, the folder was user app user, and it looks like I have to wait. Okay, it has already created my uh, output folder, which is output-webinar-demo2. So I was here, and over here it has created these files. This is the content that is coming from my Kinesis stream. So let's see what we had here. Let me download this file, which is tuples-application something something. So let me come here. By the way, my EMR cluster creation has succeeded. It has told me that the cluster is ready, and it has given me a URL to use to access my cluster. This is the URL that is for accessing the DataTorrent RTS. It is already prepared as the second step in creation of the EMR cluster. We'll eventually go there, but for now, let me look at the tuples file that I have created. So this is what is there, and this is the data that eventually came out of Kinesis stream. Each tuple has a number, a string, and another number. And this has been copied successfully by my app template into the S3 output. Now, this particular script that I ran has created the EMR cluster, and inside that it has also installed my DataTorrent RTS instance. Let me open up a tab and use that URL to access the brand new instance I have created. As I told you, it has already installed DataTorrent RTS, but the instance needs to be configured. So this wizard will guide me through the final steps of the installation. Let's see. I click on continue. It has detected the location of Hadoop, and also it is suggesting a location where actually it is suggesting a location inside the DFS, the HDFS hierarchy, where it should where it should create and use various application related artifacts. So I'm just going to accept the defaults, click on continue, and it is going to kind of configure these values in various configuration files, and based on the configuration changes I've made, it is going to restart the gateway if required, and then it is going to prompt me to enter the license. The license was already downloaded. It is this file. So let me pick this from my downloads folder. I'm going to pick that file, which is what I downloaded a few minutes ago. This is the file 311 NYV. Let me open it, upload it, send it to this web UI. It has been uploaded. So I have a valid instance with a license that allows me to run my instance for another year, where I'll be able to use this up to the limit 128 gigabytes, as Ashwin mentioned. So I'm kind of set up with this. The last step here is to actually import the Kinesis to S3 template that I just demoed. Let's wait for it to finish the import part. In the meantime, I'll go to the EMR console. It is showing me the latest EMR cluster I've created. It is starting, and if I refresh, yes, it is ready. This is the instance I created. If you remember the config properties, this is the name I gave to my cluster, which is what I see here. And over here, this one, Kinesis to S3 has been imported, and I guess I go to develop tab, go to application packages, and I can actually see that the package and the application inside the package is ready to be run. I'm not going to run it because I have already shown you the previous run. But if I enter the same data that I entered from my cheat sheet and then click on launch, I'll be able to run this particular template inside the brand new EMR cluster that I created. So this shows you the power, the simplicity, and ease of use of the templates that we have created. All you need to do is have a AWS account, download the AWS CLI, and go to the DataTorrent website, and you can start with any of the templates that are kind of listed on our AppHub website. So this is as far as using the ready-made template as a binary package. The one thing that I also would like to mention is the source code for these templates is available on GitHub. The pointer to the GitHub repository is mentioned in the web page on the DataTorrent website. Let me click on it. So this is the GitHub repository, and over here under app templates repository under the Kinesis to S3 folder, I have the source code for the app template that I just demoed. I have already cloned this repository on my computer. I am going to show you this code that I'm going to load in my Eclipse IDE. So I have already created the workspace. I have already imported the project, and let us browse the source code, and we'll see how easy it is to customize the source code to insert the processing steps that Ashwin talked about. So the template that we saw, or the actual execution we saw, does a very simple thing, which is to read from Kinesis individual tuples and send them, send those tuples out to S3 output operator, where the operator sends it out to the S3 storage in Amazon. So very simple, straightforward DAC. It doesn't actually do any processing. But if you were to add these processing steps, this particular file, application Java, shows you how to add those steps. So as an example, it actually shows you in the file that we saw, maybe over here, what this modification or customization of the template attempts to do is it is going to uppercase the second column. So the second column is alphanumeric. With these changes here, it is going to change the middle column to uppercase letters, and that modified tuple will be written out to S3. So the comments show how to do it. Let me try to do this. I mean, I'm not going to actually compile and build it to save some time, but we'll go through these comments. What the modified DAC does, it reads from Kinesis input. It gives it to, the tuples are given to a new operator called CSV parser. It will take the pipe separated columns or fields of the input tuple and gives it out as a POJO. It will give it to the transform operator. The transform operator is a customizable, runtime customizable operator, where what we are telling the operator to do is to uppercase the second column, which is called name. The output of that operator goes to the S3 output module. The output of the transform operator goes to the CSV formatter, where it takes a POJO and creates a stringified tuple. That tuple is given to the S3 output module, and this S3 output module writes it out to S3. So this is, the comments here are quite self-explanatory, and in case we follow the instructions in the comment block, we'll be able to achieve that. And if I were to do that, I can actually go to my app templates and Kinesis to S3 package. Here you'll see that I have my repository, my local copy is up to date, and it has a POM file, a README file, that we saw on GitHub, and with the POM file, I should just be able to build this project. So let me try building it. In this particular run, I have not modified the source code. So whatever output I get, if I were to run that, it would behave exactly the way my previous run did, which is it's going to copy the Kinesis input to S3 output without any changes. Uh, uh, in my project folder, under the target directory, I'll be able to see my Apex artifact getting created. It is an APA file, basically a file with AP extension, which is typically the extension of an Apex output package. So this Kinesis to S3 package has been created. I can go back to my RTS and let's say here, go to develop tab, and I'll be able to upload this package. So let's say I go here and I go to my templates workspace 2 and Kinesis to S3 target folder. The APA I can click on that and choose to upload it. So I already have this application there, so I'm just going to say upload and replace, and it will basically put this package in my instance and replace the already input package there. So this is the way, if you are a developer and you create your own Apex application, this is the way to import, or sorry, this is the way to upload your own Apex package or Apex software into the RTS instance that you have running, either on your own Hadoop cluster or in the EMR cluster that similar to what I have done. If you were to create your own EMR cluster, you will be able to load your application packages using the upload command that I just showed you. So that concludes the first half of my demo. So this was Kinesis to S3. The second half of my demo is kind of similar to the first half, except that it shows a different template. It is HDFS to S3. Now this one, the second one, because it is going to read from my local HDFS storage, I have to run it in my own Hadoop cluster. I'm not going to be running it in the EMR cluster because my HDFS is local to my Hadoop cluster. So let me go back to this this particular RTS instance I have running in my cluster. I don't have the application already imported, so let me go back. Let me go to the AppHub tab, which shows me the same templates that I saw on the DataTorrent website. Over here, I'm going to look for the HDFS app, which is here. Again, I can click on it, and it shows me the page. I'm going to import this HDFS S3. The app template is imported. So I have the package imported into my RTS instance. Now the import is similar to the upload that I did, where it actually goes to the AppHub and downloads the APA package and imports it or uploads it into this particular RTS instance. Launching this template is very easy. I just click on the launch button, and the launch dialog box is kind of tailored or customized for this application. This application copies from HDFS to S3, so it basically needs AWS credentials for the S3 side. It needs the input directory on the HDFS side, and it it actually requires the output directory path on my S3 storage. Now, HDFS, which is on my local cluster, let me go to that one, which is on node 0. Over here is my HDFS cluster. I'm going to show you the input directory where I have the files that I'm going to copy, which is under tmp test input dir. So tmp test input dir. I have a bunch of files in that directory, this HDFS directory. My application is going to copy these files on the S3 side. A very simple thing, but we'll see how easy it is to run this using RTS. So AWS credentials, I'm just going to copy these values from my cheat sheet. So let's see the AWS access key, AWS secret key. My HDFS input directory that I just showed you the contents of. The output directory, now I'm just going to kind of give it a name that's going to identify this session. So output webinar demo 2, and the bucket name is a bucket that I have already created. So I have this bucket already created. So before I launch it, let's go to my S3 and I'll show you the, so this bucket is apex.app.hdfs to S3. Apex.app.hdfs to S3. So this is where it's going to create my output directory. It's going to mirror the we'll see the output folder getting created here, and that will tell us that the application has been successfully copying data. So let me verify all my parameters, and once I'm sure, I'm going to I don't need any other launch options, so I'm just going to click on launch. It has successfully launched. Like I said before, the application has been accepted by Jan, and Jan is working on taking the package, allocating the containers, supplying the jar files to the containers, and running the application. The application has started running. This is the logical view. And because it had very few files to copy, it has already processed all these tuples. Let me go to my output side and see that it has already processed tuples. It has accepted 46 tuples, and of course it's an output operator, so it will not emit. The total emitted is into the DAG. An output operator never emits anything into the DAG, so it will always be 0. But what the output operator has done is it has written to the S3 bucket, which is listed here as one of the properties, and it has written it to the output folder that I mentioned in my launch property. So let me go back to my S3 console. Let me refresh it. As you can see, my output folder got created, output-webinar-demo2. Over here, it mirrored the input that I have here, which is temp/test/input dir. So temp test input dar, and it has created all these files. So this is nothing but the copy of the files that you saw on the HDFS side. So what the app did is quite simple, nothing magical here, but this was a very simple ingestion template. And in a typical big data situation, uh, if we had a bunch of huge files, they would get copied using the DAG that I showed you. And the other thing about this template is it will continuously scan the input directory. So as and when new files get dropped, it will automatically notice these files and copy them to the output side. And that is what the input operator does, which going back to my DAG, the HDFS input module has some sub operators. One of them is a scanner, which keeps on scanning the input directory for new files. And based on the new files that it notices, it will give it to the partitions, assuming it has created, let's look at the physical DAG view. So it has these partitions, it will give it to these partitions, and the partitions will be able to process these files in parallel. Now, so that basically concludes the second half of my demo. And I don't have, so just like the previous one, this one also has the source code made available on the GitHub. So let's say HDFS to S3. The source code is here. You can just clone it and make whatever changes you want to make. So similar to the previous one, it has an application Java file where it creates a very simple DAG, and this is what the template does. So that concludes the demo. Let me see if there are any questions. Looks like there are none, so I'll give it back to Ashwin.
All right, thank you, Sanjay.
Okay.
Let me share my screen. All right, yeah. So as you have seen, these both these templates, right? So how easy it is to import an application template and launch it, add custom logic to it, and if you don't have a in-house Hadoop cluster, you could still use cloud vendors such as AWS. Just by starting your AWS account and giving you credentials, you can get to business immediately, right? So all the background tasks such as getting your cluster, installing DataTorrent, and all of that is automated. And as a result, now you're in your application domain and you're saving a bunch of time and effort in terms of your time to production. Right. So other thing I wanted to show was I think Sanjay already kind of showed this. So if you click on the datatorrent.com/AppHub, you will find a lot more application templates here. You can drill down into any of these and then try them out. Right. So there are two views for it. One is on the website. If you don't have the DataTorrent RTS installed, you can get from here. But then if you have already downloaded and installed an application template or DataTorrent RTS, you will have access to this console, right? The DataTorrent RTS console, and then you can click on AppHub and you will see exactly the same application template. So if you want to learn more about any of these templates, you can just, for example, click on this, and then you have the high-level description for it, and then there is a video. So if you need to learn about something, you can quickly watch this walkthrough video, right? And then there are more information about this. Another thing is there is a doc as well, a walkthrough doc, and then the GitHub URL as Sanjay showed. And then if you need to give us any feedback, feel free to send an email to feedback@datatorrent.com. And then we have this Google group, dtusers@googlegroup.com. So people are asking questions there, conversing with each other, and then requesting features or any of that sort, right? So feel free to try out the templates and then send an email to dtusers@googlegroups.com. So that will help us add more features, enhance the templates, and add more templates as well. Right. So in terms of the I think in the presentation, I think the demo is done, and then I want to spend a couple of minutes on the roadmap. Right. One thing is visualizations. We talked about visualizations and application level metrics, but we did not show it in the demo because that is still in the works. Pretty soon, hopefully in a month or two, you will have the templates available with the metrics as well. So for example, if you want to look at metrics for S3 to HDFS, right? You will find metrics such as the amount of data moved, number of lines per file, number of errors, and so on, right? And then other big focus area is cloud integration. So today, sorry. Other big focus areas, cloud integrations. So today we have seen the integration for cloud templates, and we have seen Kinesis to S3, right? But then if you are in an Amazon customer and if you are on Amazon ecosystem, we want to make sure that we are able to connect to your Amazon sources and destinations and help you add the processing logic from DataTorrent perspective, right? So all the capabilities of DataTorrent on top of Amazon with your Amazon ecosystem tools. So we are building out those templates, the Kinesis to Redshift and S3 to Redshift and so on. So you could use those templates as well. And other than that, we are adding other templates continuously. So some of the ones we are working on is FTP to HDFS. So if you are continuously generating these extract files from your transactional or traditional databases, you'll be able to use the FTP to HDFS to ingest it into Hadoop, right? And then other templates are Kafka to Elasticsearch, Kafka to Cassandra, and then we are also adding processing logic, right? So Kafka to HDFS, but then you have a data preparation kind of logic in between where you do filters and transforms. Right, so that's about the roadmap, and I think that concludes the demo. So if you have any questions or anything, please feel free to ask, and do send out an email to dtusers@googlegroups.com. I think I'll hand it over to Pat to conclude the webinar.
Hey, Ashwin, there is one question.
Oh, okay, cool. So
two more questions actually.
All right. Yeah, so one is thanks for the detailed session. Okay, thank you. Thanks a lot. I hope you get a chance to try it out and let us know what you think about it. And then another question is, how about SNMP to Cassandra? We have in the past looked at reading SNMP data. Right now, we don't have a direct connector for SNMP, but if people are asking for it, then we will be happy to do that, right? So I think if you need operators and input operator to be available, the best thing to do is send an email to dtusers@googlegroups.com. So that way we can look at those requests and then prioritize internally for the operators that we are using. So as of now, we don't have an SNMP input operator, but then we can do two ways of doing it. So if you can work with us, we will build it together, or you can even contribute to the Apex Malhar library as well. So, all right, I think any more questions? I think that's all in terms of the questions. So I think over to Pat now.
Okay, thank you, Ashwin. Let me just share my screen here. Okay. So thank you everybody for attending the webinar. We will make the recording available on our YouTube channel as well as post our slides on SlideShare. Be sure to subscribe to DataTorrent's YouTube channel and SlideShare account, and follow us on Twitter @DataTorrent so you don't miss any upcoming content. Thank you for being a part of the Apex Meetup community, and we hope you enjoyed the presentation.